Hi. Hi. Welcome to vBrownbag today. My name is Scott Davis, and I'm going to talk to you about disruptive storage innovations that are going on in the industry, my company Infinio, and the impact it has on VDI-based solutions. So, I'm CTO of a startup company called Infinio. I'm fairly well known to some of the folks here. I was formerly the CTO of VMware's in-user computing business unit, and before that I was part of VMware's corporate CTO office where I covered storage and data center technologies. So let's talk a bit about where we're going to go today. So storage is an area that is subject to massive disruption in the industry. There are so many new vendors out there and so many new storage architectures that when you look around the floor here at VMworld, you can almost call it VM Storage World. So why is that? Well, virtualization by itself has changed the way we use storage and changed what the workloads look like. So that's clearly one of the disruptors. But on top of that, we have new hardware technologies like flash and its successors that give you much lower latency I/O operations in your storage stack. On top of that, applications are changing as well. Between the demands of big data, multimedia data, all of these are changing the types of what we expect from our storage infrastructure. Those changes are leading to a diversity of new architectures, whether we're talking about hybrid arrays, all-flash arrays, hyper-converged infrastructure featuring software-defined storage, cloud-based storage offerings, and decoupled architectures. And when I look at this space with Infinio, storage really has two jobs that need to get done. They need to deliver IOPS to applications, the performance that applications need, both individual latency and in bulk. And secondly, they need to provide cost-effective persistent capacity for the applications. Those are the two services that storage needs to provide. And one of the observations we've made at Infinio is that these two jobs are actually best done separately. Why is that? Well, there's a few reasons. Number one, I/O latency is best delivered closest to the application. That's right. When you have the speeds that we get from flash and its successors that are much faster than spinning media, the limitation on I/O performance is no longer disk head seek times on arrays. It's now actually interconnect that you use to get to them. And if you go over a network, a regular network or a storage area network to get your IOPS off of a centralized storage array, you're not going to get anywhere near the performance as if you move those media closer to the application, i.e. on the server. At the same time, capacity is exploding on demand, and it needs to be less and less expensive. Okay? The reason for that, so flash has been getting less and less expensive as we move forward, and all flash arrays are now down to the $1 to $2 per gigabyte range. But you have to compare that to spinning media, traditional mechanical disks, for capacity. The spinning media is in the 1 to 2 to 3 cents a gigabyte range. That's several orders of magnitude less expensive. And so if you want the optimal capacity, you want to deliver capacity with centralized mechanical media, while at the same time delivering your IOPS as close as possible to the application from the servers. So that's the landscape about how to deliver optimal storage architectures today. So what about VDI? Well, VDI came about, VMware originally discovered VDI from financial services, which was one of the first industries that were interested in this, running Windows desktops as a service. And they were interested in security and compliance, not having the data leave their data center. VMware saw that from some of our customers and said, oh great, this was at a time in the mid-2000s when VMware was basically a one-solution company. And so we were, of course, looking for workloads for our platform. So that's where VDI came from. And after it came to market, a variety of new use cases emerged, including healthcare, SLED, labs, call centers, each of them with different uses. Some of them with that security compliance, others were follow-me desktops in healthcare, remote access securely without having to open up VPN technology, etc. So lots of reasons that VDI and Windows as a service became popular. So the reasons today that people drive towards VDI solutions is, number one, it gets aligned with desktop and Windows refresh cycles, okay? So when you need to upgrade your PC infrastructure, people consider VDI. Workforce mobility, being able to work from home, being able to work remotely. getting access to your Windows applications from your smartphones and iPads and tablets, okay, are all reasons. Bring your own device complexity and security. People want to use their own devices, but you still need corporate compliance around data. So all good uses for VDI. Data security concerns. You don't want data to leave the data center. You don't want it to go away on laptops. You want to worry about loss and theft of laptops. Also, making sure that all data, all corporate data, is contained within the enterprise for e-discovery and compliance reasons. Centralized support. Windows operating system has always been painful to support for desktops. Having common images across your entire infrastructure and managing in the data center is an easier way to manage desktops. So that was another driver for VDI. And of course, as I mentioned a little earlier on the previous slide, vertical specific use cases were another driver. Virtualization, as I mentioned, disrupts storage. In general, it makes changing demands on storage. Let me quickly review what those are. So number one, you have a large set of physical machines consolidated on individual servers. That mixes up the workload coming from each server. It gives you more diversity in the applications that are sharing storage LUNs, and it concentrates them. There's also what's referred to as an I/O blender effect, meaning we're mixing workloads together. So where before a guest operating system could do specific optimizations in order to minimize disk head seek times, that gets violated in virtualized environments because the I/Os all get mixed and jumbled together, and those optimizations are hindered. There's also VMware-specific storage challenges. One of the first ones that's kind of subtle is a lot of people have deployed virtualization for rapid provisioning of VMs. It's much easier, much faster to get servers up and running. Well, under the covers, a VM provisioning operation is a big file copy. And that file copy, that VM provisioning operation, is now intermixed with the rest of your workload on your servers. So that's another big storage-specific challenge with VMware. More abstractions have more layers, and you also have less visibility between layers. VMware also has some very specific challenges around VMFS is a clustered file system or distributed volume manager, and it has cluster locking protocols involved in it, and those impact your storage as well. This used to be a bigger issue. Now there are VAI primitives that are also a storage challenge that accelerate some of those, but it still means differences for your storage arrays in a VMware environment. And of course, workload mobility, vMotion, DRS, etc. These are all VMware-specific operations that change the workload profile you see in your storage arrays. Lastly, VDI has some unique challenges. VDI in particular, with VDI, you want the cost of your virtual desktops to be equal or less than physical desktops. That's sometimes difficult to achieve. So one of the things that customers typically do is they have higher consolidation ratios. But with higher consolidation ratios comes greater load on storage. Not necessarily capacity, but IOPS, and a specific kind of IOP. Server workloads are typically a bandwidth, throughput, kind of batch-oriented amount of I/O that you can get through a storage array. VDI is driven by interactive latency of individual I/O operations, and you very much need to get at least 25 I/Os per second per virtual desktop out of your storage array, and in the flash expectation area, you actually may want a good bit more than that for a peppy, good user experience. So that's a huge challenge on storage arrays with VDI that needs to be met. You're also running, as part of that cost equivalent, you're now running shared data center hardware instead of desktop hardware as well. Last but not least, VDI also has synchronized spikes, boot storms, everybody coming in at 9 a.m. and logging in, antivirus scans, antivirus updates. These are all time-oriented operations that can occur across all of your VDI VMs at the same time, again, triggering huge I/O spikes that need to be met by your storage infrastructure. So those were a lot of differentiations with virtualization and storage, weren't there? So let's talk about how the storage landscape and the flash technologies that I mentioned earlier have arisen to address these challenges. So there's two new forms of traditional storage array, dedicated storage appliances out there in the industry. One of them is hybrid arrays. Hybrid arrays are commonplace now. Startups arose from hybrid arrays, but all the mainstream vendors all have hybrid arrays as well now. And this is basically an array that is a mixture of spinning media and flash. And the flash is typically used as an internal cache for the storage array. It's used as a write log buffer, and it's used as a read cache for your hot data. And different models of arrays have different levels of effectiveness in how we balance the workloads between those elements. All flash arrays are the latest thing in storage appliances, and this is no spinning media whatsoever. The user data is stored directly on flash. When I give a longer version of this disruptions talk, I talk about all the details about why a flash is complex for a storage software to handle. I'm not going to get into that today, but different arrays have different levels of sophistication in how you handle all flash. So all flash is great, but as I mentioned earlier, these can be expensive, and all workloads don't necessarily need that IOP, the expense of the capacity, in order to deliver those IOPs. There's also server-side storage. And the generic term here is software-defined storage, meaning that your storage stack is now executing co-located with your applications on a server. There's a specific form of sales strategy around this called hyper-converged infrastructure, which is various vendors selling building blocks, if you will, that contain compute, storage, and memory all together in one unit. And as a data center building block, you aggregate them together and then carve them up to for application usage with management automation as well. So a variety of vendors are selling this now. VMware recently got into the space here with their Evo Rails line that's based on vSAN. There's other variety of startups that are in the space. Nutanix is the most well-known one, or SimpliVity. So this is about hyper-converged infrastructure, buying it as a building block with software-defined storage. The same principles, though, of being able to use software-defined storage is also prevalent in a fourth category, what I call decoupled architecture, which is separating your performance for capacity as two different layers. But you can do that with existing storage as well. And that is exactly what Infinio does, that I'm going to talk to you about in a moment. So the bottom line for VDI is I've shown you a bunch of new architectures. They all have value, depending on your data center infrastructure and your use case. For VDI, you really want to know your goals, know your cost economics, know what kind of user experience you want to deliver for the particular desktop applications you're running in your VDI infrastructure, and how you want to management, what your operations look like internally. One size definitely does not fit all. Not telling you to buy any one of these particular solutions. They all have value for different use cases. So how does Infinio fit into this landscape? Well, Infinio is great at delivering good user experience for your desktops. Infinio is a distributed, scale-out I/O performance layer implemented entirely in software. And for VDI workloads in particular, number one, it reduces latency and delivers in-memory access times for your workloads. Basically, it delivers you the performance of all flash arrays out of entirely software for your VDI workloads. You reduce latency, we eliminate I/O spikes, round them out, okay, eliminate those I/O storms that I mentioned earlier. And it gives you better economics for VDI. That IOPS, the IOPS per desktop, is more expensive in arrays than capacity typically is, especially if you're looking at all flash arrays for your VDI infrastructure. So Infinio improves that. It's great at fixing stalled deployments. A lot of times VDI would be configured in order to meet the cost equation that I mentioned earlier, has under-configured IOPS per desktop. Works fine in the proof of concept, but when you start scaling it out in bulk, in mass, users start complaining about increasingly bad user experience. Excuse me. Increasingly bad user experience because you don't have enough IOPS per virtual desktop at scale. Infinio is a great fix for that without requiring new hardware, without having to upgrade your storage infrastructure. So we can fix stall deployments. Technology is applicable to both the Citrix technologies as well as Horizon View, and you can intermix server and desktop workloads as well. About a third of Infinio's customers are using it for VDI, although Infinio is a horizontal solution, as I think I mentioned. And they're typically using it for these reasons, reducing your disk I/O, reducing bandwidth, increasingly improved user experience. One of our reference customers, Mastergy, avoided spending hundreds of thousands of dollars on an all-flash array upgrade for their VDI infrastructure. We've also had various customers using hybrid array architectures with spikes when the flash gets flushed, and they get a great experience with Infinio. So it's a great solution for VDI. How does it actually work? Well, this is what our technology platform looks like. We are well integrated with vSphere and ESX. We have an I/O intercept that runs as a kernel mode plugin, what's called a PSA intercept in VMware's multipathing filtering technology, and that inserts itself in the I/O stream. We then have a distributed cache appliance that runs on each node that delivers read hits out of memory. Now, uniquely in our, and there is one management console per ESX cluster. So this is a completely distributed, seamless scale-out cluster, delivering your IOPS out of memory. So how does it do that? Well, what's very unique about Infinio is that we actually have a global content-aware dedupe architecture. That's right, we're dynamically identifying common content across all your VM images and caching them once, making optimal use of physical memory, giving high dedupe rates and fast access to the most amount of data that you can see. This is especially good for VDI, because think about all the shared content across VDI images that can be cached now in this manner. So there's the gold master images for your operating system. There's the common applications across all the VDI instances. There's cacheable web application data. All of this can get served up dynamically out of memory instead of going to your slower storage array, giving you a much peppier user experience. Infinio is operationally transparent. Okay, we don't create any new data stores, unlike other solutions in this space. It's not like it's a new array where you have to now create new data stores and provision all your virtual desktops to it. We insert ourselves seamlessly in front of your existing storage array, and we're completely transparent to all of the operational procedures, such as backup and patching, various virtualization-centric operations like snapshot and replication, regardless of what layer those occur at, whether they're in the vSphere layer or in your storage array. We're transparent to vMotion. We're transparent to VAI acceleration primitives on arrays, etc. It's very simple to evaluate. You can actually install Infinio in less than 30 minutes. It's a single OVA package that you install. It unwraps itself. It queries Virtual Center using Vim APIs to determine your topology. It starts up our cache on each node and then presents you with a simple user interface that lets you decide which data stores you want to accelerate. Then you're off and running. You can deinstall it just as easily. There's no changes to any of your data structures, so it can be removed easily as well. Here's a slide that shows some VDI results from one specific customer. We typically can see anywhere from 60 to 80 or 90% offloads with Infinio, and we typically deliver I/O operations in under a millisecond out of Infinio. So in particular, we like to say that with a VDI deployment and an overloaded storage array, we can return that array to what it worked as when it was pristine and new, back to its new state, as opposed to what happens over time with these arrays where you can get tens of milliseconds per I/O operation, resulting in slow desktops. So the net result is that Infinio delivers results for VDI, better end-user experience, reduced latency by caching all this shared content, delivering it from memory efficiently, much better handling of peak usage, such as boot and login storms. We can fix stalled deployments, which have under-configured storage in order because of that pricing equation that I mentioned earlier. It's easy to evaluate and try, no disruption, no modifying your data stores. You can remove it just as easily, so it's very low risk. And it leverages your existing storage investment. I mentioned prices earlier between what flash costs per gigabyte in an all-flash array versus what mechanical disks are. Well, you know, not only are mechanical disks in the 1 to 3 cents per gigabyte range, you know, there's even cheaper storage than that. Yeah, it's the storage you already own that's already paid for in your data center. Infinio is a way to deliver all-flash performance on that existing all-capacity on that existing capacity array that you already have and get more life out of your existing hardware. So that's Infinio for VDI and the impact of virtual desktops and storage disruptions. And I hope that was an informative talk for you today. Thanks to the vBrownbag folks for letting me do this.